Hi all, welcome to this, the last video that we're going to be looking at in the series looking at the atmosphere, atmospheric circulation and all the other things we've talked about so far. In today's video, it's a little bit of a wrap up. We've got a couple of different things that we need to look at. And I'm going to try and keep this one reasonably brief, so bear with me if I'm going reasonably quickly through things. So today we're going to be looking at Rossby waves in the jet stream, we're going to be looking at thermohaline circulation, and we're going to have a very, very brief look at El Nino and La Nina. Now, as I say, these things, I've said this in lessons, they don't come up as discrete questions in the exam, which is why we're not spending a huge amount of time on these, but they are things that can enhance your understanding about how the atmosphere as a system operates. So without further ado, let's start with talking about jet streams and Rossby waves. Now, in both the the northern and southern hemispheres, where you've got different bands of air meeting, so where the cells meet, you get jet streams. Now what this is a band of wind that moves around the Earth reasonably quickly, particularly quickly where we've got the feral and polar cells meeting, because we've got a larger difference in terms of the temperature difference between the two masses of air, and they move around the Earth from west to east. Now, as these bands of air move around the Earth, they undulate. They don't just move in one straight line, as we've got differences in heating over oceans, over land, over different areas of land or oceans. That causes these bands of air to move. And you can see here that they actually start to move in quite a pronounced fashion. Now what this does eventually is it brings cold air down into areas where we expect there to be warm air, and vice versa. It brings warm air up into areas where we expect there to be cold air. And this is our Rossby wave. And eventually we're going to wind up in a position where sometimes these get nipped off. So this here is just going to complete across, and it's going to isolate a little patch of cold air down here, and we could see the same here where this patch of warm air gets isolated up north, and another patch getting isolated down south of colder air. And this gives rise to anomalies in weather patterns. So we've got the jet stream, gives us an area of very high, fast-flowing wind, and the Rossby waves are areas of isolated hot or cold air that give us anomalies in the normal weather patterns that we would expect these areas to have. Now, next, this is thermohaline circulation. Now, as a diagram, I'm hoping that you see some similarities between this and the diagrams that we've already seen about global oceanic circulation. Now, when we were talking about that, we discussed how oceanic circulation is driven by differences in heat. And while that's true, it's not the whole picture. We also have differences in density and salinity to consider. Now, when we talk about thermohaline circulation, we're talking about all three of these things. Now, our simple rule of thumb is that warmer, less dense water travels on top of colder, more dense water. Water is less dense if it's less saline. So when we introduce fresh water into an area, and I'm going to need to pause because the tannoy is about to go, and I'm sorry if this is just staggered horribly, but the tannoy went. So when we've got this circulation, if we get areas where we have got colder, more dense, more saline water entering the system, for example, up here where we've got the water coming down as the Labrador current, it comes down, and by the time it makes it in any of these areas, it helps to create an upwelling of water because it hits warmer, slightly less dense water, and it drives it up to the surface. And as it drives it to the surface, it gets heated and it continues to move around. Now, one of the big things that occurs as part of this is it releases a lot of nutrients into the water column, and it helps to create really rich fishing grounds. You know, particularly in the areas where you've got these kind of bubbles saying heat release to air. These are areas where we get upwellings of water, so we get a lot of mixing going on, and thanks to this thermohaline circulation, where we've got colder, more dense, more saline water pushing less dense, warmer, less saline water up, it drives the circulation of the world's oceans. And this happens in addition to the circulation patterns that we've been talking about earlier in class. And that's why I say you can see in this diagram there's a lot of overlap to the global oceanic circulations diagram that we've already looked at. Now, next, El Nino and La Nina. Now, El Nino and La Nina are a little bit different in that they are fairly, not exceptional, they are events that occur regularly, but they can have a large impact. Now, where they're a little different for us is that they are Pacific Ocean events, they're not Atlantic Ocean, which is where we've been focusing on. Now, what are they? El Nino, first, well, El Nino is caused by a warming of air in the central or the eastern tropical Pacific. Now, that word tropical here is reasonably important. We are talking about the warming in an area where we are between the tropics. And what does it do? What is the impact of this? Well, it causes a lot of changes. The changes, well, the trade winds get weaker or they reverse. You can actually have instances where in the central Pacific, the trade winds don't blow northeast to southwest, they blow from west to east. And it's because we've got this air warming and it reverses some of the circulation cells that we've seen. Now, when we're looking at this in class, we can have a little look at something called Walker circulation cells, which have a big impact on this. Now, in addition to this, it pushes rainfall to the central Pacific away from Asia particularly. And that can result in a lot of droughts and things like that in Asian areas. And when we look at the central Pacific, it receives a lot more rainfall. Something else that we see is we've got less upwelling of nutrients, and that means we've got less fish, which can have a big impact in the eastern Pacific particularly. Now, the other one, and my animations have went a bit wrong here, I clicked the wrong thing. La Nina is caused by the opposite. It's caused by a cooling in the central or eastern tropical Pacific. And what are the impacts of that? Well, again, it's similar, but reversed. So we get the trade winds get stronger. Rainfall moves west rather than east, and it moves towards the Indian Ocean or Australia. Western South America, obviously, receives a lot less rainfall. And this also means that we see more upwelling of nutrients, and thus more fish, and I've forgot a space in my PowerPoint, in the eastern Pacific. Now, all told, what are the impacts of these things? Because that's where it can become important. El Nino, the big impacts we're looking at. The eastern Pacific, we've got more rainfall, so we can get flooding. We've also got increased temperatures in places like Australia, which can result in bushfires. Also not helped by the fact that the rainfall that region should have gotten has moved into the central Pacific. It disrupts the monsoon in India. Now that can be really, really pronounced. A lot of farming in India depends on monsoon rainfall. Less monsoon rainfall, less farming, can lead to starvation. We see similar things actually happening in Africa as well sometimes. It's how pronounced the effect of El Nino can be. What about La Nina? Some of the impacts it has. We see increased rainfall over Australia and Indonesia because that rain has been pushed the other way. And yes, it does mean that Australia would see fewer bushfires, which is a good thing, but it also means they've got more of a chance of seeing more tropical storms, which is obviously a negative. We do see more fish in the eastern Pacific, which increases the amount of money that can be made by fishing-based communities. And I flicked onto a black screen. And that kind of wraps things up, guys. Now, there is way more to this, particularly El Nino and La Nina. They are whole topics all on their own. But I like to give us a little bit of a glance into what they're about, what some of the impacts of them could be, and we can maybe discuss them more during lessons. This is going to be at the end of the videos now, and also that's the last video before the summer break. So I'll see you in class on Tuesday, and until then, I'll see you later. Bye.